Hi everyone, welcome to goclasses. So let's start this session now. Please tell me, is the audio video volume, is everything clear? Okay. So in this session we will continue these standard questions we were solving in the last session. Timestamp based protocol in the concurrency control protocols. This protocol we were learning timestamp protocol. In the last lecture we have seen 50 questions on this protocol. Okay. So you can watch the last lecture, timestamp protocol 50 questions. After solving those 50 questions, definitely you will become basically expert of this of this protocol. Okay, for this timestamp protocol you will become expert. So now in this session we will continue the standard questions that we were solving. So let's continue that, and we will solve some more standard questions like questions from the Ullman. Okay, so this is the content for this lecture. The content is basically timestamp protocol standard questions, and when I say standard questions, it means Ullman exercise questions, Washington University questions. These questions we will solve. So this is a part 2. Remember, the part 1 you can watch on the GoClasses YouTube channel, or you can find the link in the description. Okay, so you can check out the description, the link you will find. So let's start now. Okay, so let's start with this session. So in the last lecture we have seen that this timestamp protocol, it does not ensure recoverability. Correct? This is what we have seen. So let me tell you the recap. The recap is basically that this timestamp protocol doesn't ensure recoverability. Correct? It doesn't ensure recoverability. Okay, so it doesn't ensure recoverability. It ensures, this timestamp protocol, it ensures your conflict serializability. It ensures the conflict serializability. Okay, but it does not ensure recoverability. Correct? So what can we do such that, like in this TSP, what how can we make sure that it allows only recoverable schedule, it generates only recoverable schedule. So this basically what I'm saying that TSP plus this recoverability. So how to make sure that? So let me tell you that what you can do. Very easy, you can do that this TSP, and you can make sure that only strict schedules are allowed. TSP plus strict schedules. This is called strict TSP. Okay, strict timestamp protocol. This is called strict timestamp protocol. So what is this strict timestamp protocol? Let me tell you. Remember the concept of strict schedule. What is the strict schedule? So the idea is like this. First of all, you understand what is the strict schedule. That we have already seen. What is a strict schedule? So what is the definition? The definition of strict schedule is that if there is a transaction and it is writing some item. So let's assume it is writing item X, and let's assume this T2 needs to read item X. Okay, that is written by this T1. So this strict schedule, what it says that if this transaction T1 is writing item X, then until it commits or abort, this T1 cannot write item X. Okay, so what I am saying that in this duration you cannot read or write. Here you can read or write. So until it commits. So in this duration, look at this duration. In this duration you can see, basically you cannot read, no write X, no read X. Okay, this type of schedule is called strict schedule. We call it strict schedule. This is the definition of strict schedule. Correct? Now this same idea we can apply, and we can make sure recoverability. We can ensure recoverability. So what you can do, in this in this timestamp protocol, you can implement this idea, this strictness idea you can implement. Okay, and then if you implement this strictness idea, you will call it strict TSP, strict timestamp protocol. Okay, so what this says, this strict timestamp protocol, what this says, it is same as TSP, but the only difference is, remember this strict timestamp protocol, all the rules of TSP will be there. All the rules of TSP will be there. Remember, please understand that all rules of TSP will be there. In the last class, we have already seen all rules of TSP will be there. One additional rule will be there. What is the additional rule? The additional rule is that if some transaction writes the item, if some transaction will write the item, okay, then if this another transaction want to read or write this item X, then it has to wait. If you want to read or write item X, either you want to read item X or you want to write item X, then you have to wait until the commit or abort. Until the commit or abort. You have to wait until the commit or abort. Okay. So this basically this wait you have to do. I can say this wait you have to do. Okay. You have to wait until the commit or abort of this transaction T1. Okay. Remember this point that of course this timestamp of T1 is less than timestamp of T2, because if T1 timestamp is more, okay, if this what I'm saying that if this T1 timestamp is more, then I can say if this T1 timestamp is more, then definitely what will happen, then this will abort, right? Then this will not wait. See what I'm saying. This is what I'm saying, that if let's assume T1 timestamp is more than T2, okay, then in this situation, this T1 has already written item X. Now, if this T2 wants to write item X, then what will happen at this point? What will happen? Because T1 is younger transaction. T1 has more timestamp. T1 is younger transaction. T1 has already written item X. So definitely at this point of time, what will happen? At this time, T2 will roll back. Correct? At this point, T2 will roll back. Okay. So this is the points. Same point for read operation also. If this is T1 and this is T2, if T1 has more timestamp than T2, and this T1 has already written item X and this T2 wants to write item X, then again at this point of time, what will happen? At this point of time, T2 again will roll back. This is what happens in the TSP. This is what happens in the TSP. So, but what I am saying that in the TSP, you tell me a simple question. I'm asking very simple question. Let's assume there is a transaction T1, there is a transaction T2, and transaction T1 timestamp is less than transaction T2 timestamp. Okay, this transaction T1 timestamp is less than transaction T2 timestamp. Now, this simple question I'm asking that if this T1 writes item X, okay, and because remember this T2 is younger transaction. This T2 is basically, this is the younger transaction, and in the timestamp protocol, this is the serializability order. This is the serializability order. Okay, and this T2 is a younger transaction. So in this timestamp protocol, you can see that if this T1 is writing item X, then no problem, this T2 can read item X, right? Okay, there is no problem. This will be basically allowed. This will be basically allowed. Okay, you can easily see this will be allowed in the timestamp protocol. But in the strict timestamp protocol, what will happen? In the strict timestamp protocol, let's talk about strict timestamp protocol. In the strict timestamp protocol, what will happen? In this strict timestamp protocol, this will not be allowed. Okay, this read will not be allowed because this is a strict timestamp protocol. Strict timestamp protocol means this T1 is writing item X, okay, and this T2 want to read item X, then this will not be allowed. This will be delayed. This will be delayed, or I can say this will be wait. So T2 waits. This will be delayed. This operation will be delayed. It will be delayed till when? This operation will be delayed till when? Until it commits or abort. Until it commit or abort. Okay, until it commit or abort, it will be delayed. So here this operation will be basically delayed. This operation will be delayed until this T1 commits or aborts. This is what happens in the strict timestamp protocol. So this is the complete explanation of what is timestamp protocol and what is strict timestamp protocol. So I hope you understood. Okay, so let's see this. So you can see this is strict timestamp ordering protocol. In this strict timestamp ordering protocol, what will happen? So it will allow only strict schedules. Okay, it will, of course, it will ensure the conflict serializability. So this conflict serializability will be ensured by timestamp protocol, and this strict timestamp protocol, it will allow only strict schedules. So what is the concept? The concept is very simple, that if you want to read or write, okay, like the concept is extremely simple. What this strict timestamp protocol says, this strict timestamp protocol says that, it says that if you want to, like, let's assume this T1 and this T2. So if you want to write or read item X, if you want to read or write item X, which is already written by T1, then what you have to do, then basically you have to wait until this commit, until this commit or abort, until this commit or abort. If you want to do, then you have to wait. Okay, so for example, let's assume this T1 wants to read item X or write item X. This T2 wants to read item X or write item X. Then this will have to wait. At this point of time, this will be delayed. This will be delayed. Okay, and this will happen here. So you can see this will be delayed until this T1 commits or aborts. Okay, so this is the concept of strict timestamp protocol. So very simple protocol. Now let's see some questions. You will answer all the questions that I'm asking. Okay, back to back I will answer. I will ask you all the standard questions. I will ask you, and you have to answer all the questions. Okay, so let's see this question. This is a question on timestamp protocol. This is Washington University question. Okay, all these questions back to back, I'm taking all the questions, all these different variations I'm taking, and all these variations are from Washington University. So these are standard questions. Okay, what this question is saying, so let's see this. Let's see the first question. First of all, let me tell you that STI means that transaction is starting. Okay, the question is saying that STI means that transaction starts, and COI means transaction commits. Okay, and we have a timestamp scheduler. Okay, we have a timestamp scheduler. The timestamp scheduler will allocate timestamp to transaction in the order of their start. Okay, so let's see this. Let's see the first question. So you can see which transaction is starting first. Tell me. In this is your question number first question. So tell me which transaction is starting first. Which transaction? So you can see transaction number 1 is starting first. So you have transaction number 1, then you have transaction number 2, and remember transaction 1 starts first. So this transaction number 1 is basically older transaction, and this transaction number 2 is basically younger transaction. Okay, and the timestamp of T2, you can see that timestamp of T2 is greater than timestamp of T1. Okay, so this is the question that is given to you, because you can easily see that this means transaction. What it means? It means transaction T2, first transaction T1 is starting. Okay, so here transaction T1 starts. So here you will get this transaction T1 will get a timestamp. After that, this transaction T2 will start. Okay, after that, what will happen? This transaction T2 will start, and this T2 will also get a timestamp. Okay, so this T2 will also get a timestamp. So you can see that T1 timestamp is less than T2 timestamp, because timestamp always increases. Okay, now you tell me. So this is reading item A. It is reading item A. Then it is reading item A. Then it is writing item B. And then it is writing item B. Okay, it is writing item B. So tell me, in the timestamp protocol, keep timestamp protocol in mind. In the timestamp protocol, you tell me a simple question. In timestamp protocol, will this be allowed? Will this schedule be allowed? Tell me, because remember, in the timestamp protocol, this is the order of conflict. This is the scheduling order. Okay, in the timestamp protocol, this is the scheduling order, correct? This is the scheduling order. You already know this. You already know this is the scheduling order. Sorry, this is the serializability order. Sorry, this is the serializability order. So tell me, is there any problem? Under the timestamp protocol, is there any problem? Remember, T1 timestamp is less than T2 timestamp. Okay, so timestamp protocol says that your serializability order will be in the order of their timestamp. Okay, so in this order things should happen. This is the order of conflict operations. So you can just simply say that this, look at this order. So this is the order of conflict operations. Order of conflict operations. This should be the order of conflict operations. So you can see, yes, this is the order of conflict operations, like this is a conflict operation. So this is fine, correct? This is fine, there is no problem. So finally this will be allowed. So I can say what action will be taken? What action will be taken for W2? This will be, this operation will be allowed by timestamp protocol. Okay, allowed by timestamp protocol. This action will be allowed by timestamp protocol because there is no problem. Remember this point. Remember a simple point, that in the timestamp protocol, in this timestamp protocol, the serializability order, or I can say in this protocol, the conflict operation order, the conflict operation order will be same as your timestamp order, of transactions, timestamp order of transactions. Okay, so let's see. Anyway, so let's come to this question. Tell me the answer for this one. Tell me the answer for this one. What action will be taken for W1A? In this question, what action will be taken for W1A? So first transaction T1 is starting. So here transaction T1 will get a timestamp. Then transaction T2 is starting. T2 will also get a timestamp. So you can notice T1 timestamp is less than T2 timestamp. Okay. Now this is the question, and this is T1, this is T2. This timestamp, T1 timestamp is less than T2 timestamp, and the question is saying that first this is reading item A, then it is commit, it is reading item A, then it is commit, and then it is reading item A, and then it is writing item A. Okay, so you tell me what action will be taken for this operation, for this W1A? What action will be taken for this W1A? What action is going to be taken for this W1A? The answer is very simple. This will be rollback. Yes or no? Because this is not allowed. Correct. Remember, this is the order of, this is the serializability order. This is the order of conflict operations. The conflict operations should happen in this order. So you can easily see this. I can say conflict operations should happen in this order. Conflict operations must happen in this order. Must happen in this order. Must happen in this order. So you can easily see that this is definitely not allowed. Okay, this is definitely not allowed. So in this situation, what will happen? Your T1 will roll back. Okay, so at this point of time, I can say that T1 will roll back. Okay, T1 is going to roll back, right? Yes or no? T1 will roll back at this point of time. So this will be, I can say this will be your unsuccessful. This is unsuccessful. This is unsuccessful, and here I can say T1 rollbacks. T1 rollbacks. Okay, let's see the next question. Tell me the answer for this one. What is the answer for this question? Okay, let's see this one. So what is the answer here? So you have three transactions now. T1, T2, T3. There are three transactions. It means transaction T1 got timestamp. It means transaction T2 got timestamp. It means transaction T3 got timestamp. Okay, so all the transactions, they got timestamp. This transaction T3 got timestamp. So this is the order of timestamps. Okay, T1 timestamp is less than T2 timestamp is less than T3 timestamp. So you have these transactions T1, T2, T3. These are the three transactions, and this is the order of timestamp. This is the timestamp order. Now you tell me what happens when you do W2A. So this is reading item A. Okay, then this is writing item A. Is this allowed? Tell me. A simple question I'm asking. Is this allowed? Is this allowed? Is this allowed? Remember, this is the order of conflict operations. The conflict operations must happen in this order. This is the serializability order. The conflict operations must happen in this order. So is this allowed? Tell me, is this allowed or not? Yes, this is fine. Yes or no? There is no problem. This is perfectly fine. This is allowed. Okay. Now after this, this is commit. After this will commit. Okay, this is committing. After that, it will read B. After that, it is reading B. It is reading B. Okay, so it is reading B. There, that is also fine. There is no problem. Okay, next, then it is writing A. Then it is writing A. Okay, so this is writing A. You tell me a simple question I am asking. So this is not allowed. Yes or no? Correct. This is definitely not allowed. This is definitely not allowed in the timestamp protocol. So at this point of time, what will happen? I can say this T2 will roll back. So this is the action that will be taken, that T2 will roll back. Okay. T2 roll back here. Transaction T2 will roll back here. So remember this as T2, it means start of transaction T2. It means start of transaction T2. Transaction T2. Okay. So this simply means that your transaction T2 is starting. So here you can say this T2 will roll back. This transaction T2 will roll back. You tell me a simple question again. In the Thomas Wright rule, what will happen? If you use TSP with Thomas Wright rule. If you use Thomas Wright rule, then what will happen? If you use Thomas Wright rule, then what is going to happen? If you use Thomas Wright rule. This Thomas Wright rule, if you use, then what will happen? Then remember this will be ignored. Okay, this will be ignored. So here the answer will be this will be ignored. No rollback will happen. Yes or no? This will be ignored. Correct or not? This is going to be ignored. So you can see this action will be taken for this W2A. For this W2A, this operation will be ignored. This operation is going to be ignored in the Thomas Wright rule. So using the Thomas Wright rule, this operation is going to be ignored. The question is asking what action will be taken for W2A. Okay, read the question. Read the question, what the question is asking. The question is asking what action will be taken for W2A. Okay, action. What action will be taken for W2A? So for W2A, what action we will take? So W2A, we will ignore. Here we will ignore. Okay, here we will roll back. Here transaction T2 will roll back. So in the normal timestamp protocol, this is what happens in the normal timestamp protocol. And this is what happens in the Thomas Wright rule. This is what happens in the Thomas Wright rule. If you have Thomas Wright rule. So using the Thomas Wright rule, this happens. Correct? Yes or no? Now let's see this question. So tell me the answer quickly. Tell me the answer for this one. So again here you have three transactions T1, T2, T3. These are the three transactions. The order, this is the starting order. First T1 is starting, then T2 is starting, then T3 is starting. Okay, so T1 is starting, then T2 is starting, then T3 is starting. So this is the timestamp order of transactions. Okay, now this is the order of conflict operations. This is the serializability order. You know, this is the serializability order. This is the serializability order. In this order, conflict operations must appear in this order. Okay, now what? Now this is reading item A. This is reading item A. Then this is writing item A. Okay, then this is writing item A. Then this is reading item A. This is perfectly fine. Yes or no? This is perfectly fine. There is no problem. Correct? This is perfectly fine. So this will be simply allowed. This operation will be simply allowed. What action will be taken for this operation? This operation will be simply allowed. Okay. Let's see the next question. The last one. So tell me the answer. What action will be taken for R2A? Again, you have three transactions. First transaction T1 is starting, then T2 is starting, then T3 is starting. So you have three transactions. There are three transactions T1, then T2, then T3. You have three transactions. And they are starting in this order. First T1 is starting, then T2 is starting, then T3 is starting. So they will get timestamp. The timestamp of T1 is less than timestamp of T2. And timestamp of T2 is less than timestamp of T3. So this is the serializability order. This is the order of serializability. Now what operations are happening? You can see that T1 is performing a read operation. Then this is performing write operation on it. This is perfectly fine. Yes or no? This is perfectly fine. There is no problem. We don't have any problem here. Then this is writing item A. This is also perfectly fine. This is also perfectly fine. There is no problem. In this order, conflict operations can happen. And then what is happening? Then this is reading item A. Then what is happening? This is reading item A. Okay. So this R2. So this is definitely not allowed. Correct. So I can say it will not be allowed. It will not be allowed. Okay, so this is not going to be allowed. So at this point of time, what will happen? What action will be taken? The action that will be taken is this will be gone. I can say this T2 will roll back. Okay, transaction T2 is going to roll back. So this option will this will happen. Transaction T2 will roll back. Okay, SG entire transaction T2 will roll back. This transaction T2 this is going to roll back. Okay, this entire transaction will roll back. The rollback happens for the transaction, not for the operation. Okay, so this operation will not roll back. The transaction will roll back. Okay, this transaction T2 will roll back. So transaction T2 will roll back here. What about Thomas Wright rule? What about Thomas Wright rule? Tell me. In case of Thomas Wright rule, what can you say? What can you say about Thomas Wright rule? In case of Thomas Wright rule, what you can say? Tell me. What can we say in the case of Thomas Wright rule? Nothing will change. Remember, in the Thomas Wright rule also T2 will roll back. Okay, T2 will roll back. In the case of Thomas Wright rule also T2 will roll back, because remember, this is read operation. This is not write conflict. Okay, this is not write conflict. This is read operation. So again, this will not be allowed in the Thomas Wright rule. In the Thomas Wright rule, again, this will not be allowed. Okay, so remember this point. So this is something that, remember, what is timestamp protocol versus Thomas Wright rule? What is the difference between these two? What is the difference? The only difference is, remember, the only difference. The only difference happens when this type of situation you have. When you have this type of situation. Okay, when you have this type of situation. In this type of situation, the only difference happens in this type of situation. So you can clearly see here what will happen. So this will be ignored by Thomas Wright rule, and this will be, I can say, here T2 rollback, here T1 rollback for timestamp protocol. T1 rollback by timestamp protocol. This is the only difference. Okay, this is the only difference. This is ignored by Thomas Wright rule, and here T1 will roll back by timestamp protocol. This is the only difference. So this is important, that this is the only difference between these two. Okay, so these are the questions. Tell me, all the questions that we have seen so far, are they clear? These are the Washington University question. Are you comfortable? All the Washington University question that we have seen, are you comfortable? Total 4 or 5 questions we have seen. Did you understand? Did you clearly understand all of them? Tell me. Okay, now let's see some GATE exam questions. So tell me about this one. This is a GATE 2010 question. GATE 2010, transaction and concurrency. Which of the following concurrency control protocols ensure both conflict serializability and freedom from deadlock? Freedom from deadlock. So the answer will be timestamp ordering. Okay, answer is going to be timestamp ordering. So here the answer will be second, because remember, both of them will, one thing I want to tell you, that both of them will ensure conflict serializability. So this will also ensure, this conflict serializability will be ensured, but suffers from deadlock. Suffers from deadlock, right? Okay, suffers from deadlock. So conflict serializability will be ensured. There is no problem in the conflict serializability. Conflict serializability is ensured by the two-phase locking protocol, but it suffers from the deadlock. And this is free from deadlock. This is free from deadlock. Why? What is the reason? What is the reason this is free from deadlock? Tell me, what is the reason this is free from deadlock? This is free from deadlock because no one ever waits. Because no transaction ever waits. Correct? because no transaction ever waits. Because no transaction ever waits. No transaction will never, there is no transaction which will ever wait. So you can see this is free from deadlock. So the answer will be second only. Okay. Timestamp protocol is free from deadlock because no transaction will ever wait. Now let's see the next question. Tell me the answer for this one. This is GATE 2019 question, a very recent question this is. So the question is saying consider the following two statements about database transaction schedules. Consider the following two statements about database transaction schedules. Okay. The question is saying strict two-phase locking protocol, strict two-phase locking protocol, strict 2PL. It will generate conflict serializable schedules that are also recoverable. Yes, this is correct. This is the purpose of strict 2PL. In the strict 2PL, what we do, let me tell you. In the strict 2PL, what we do, in this strict two-phase locking protocol, what we do, any transaction, whatever transaction you take, all the exclusive lock will be held until the commit operation. Okay, all the exclusive lock will be held until the commit or abort operation. So this is the commit or abort. Then if you have taken some exclusive lock on X, some exclusive lock if you have taken on item A, then remember this exclusive lock will be released only after the commit operation. You can release it only after the commit operation. You can release it. The shared lock you can release at any point of time, no problem. The shared lock you can release at any point of time, but this exclusive lock must be released after the commit operation. Okay, after the commit or abort operation, this exclusive lock must be released. This is what strict 2PL says. So strict 2PL basically gives you strict schedules. First of all, it gives you strict schedules. Strict schedules automatically means recoverable. Okay, recoverable. So strict schedules that automatically means it will give you recoverable schedules, and also cascade-less schedules. Also cascade-less schedules. So recoverable and cascade-less schedules you will get. And because of this strict, so all these things are happening because of this strict. Because of this strict, all these things are happening. And because of this 2PL, conflict serializability will be guaranteed. Okay, the conflict serializability is guaranteed. So this is the concept of strict 2PL. So strict 2PL will guarantee conflict serializability. Conflict serializability is guaranteed, and also recoverability is guaranteed. Now, what about the next? Timestamp ordering concurrency control protocol with Thomas Wright rule can generate view serializable schedules that are not conflict serializable. This is also correct. This is also correct. I told you that Thomas Wright rule does not ensure conflict serializability. This we have already seen. That timestamp protocol with Thomas Wright rule. Okay, this timestamp protocol with Thomas Wright rule doesn't ensure conflict serializability. This we have already seen. Doesn't ensure conflict serializability. In the last lecture, we have already seen this, that it doesn't ensure conflict serializability. This conflict serializability is not ensured. Okay, so this I can say it will not ensure, because you can easily see that this timestamp protocol with the Thomas Wright rule, because of this Thomas Wright rule, what will happen? You can generate view serializable schedules which are not conflict serializable. You can, for example, you can see this T1, T2, T3. This example you can see like this is reading, and let's assume this is the order of timestamp. This is the timestamp order. This is reading item X, then this is writing item X. Then let's assume this is writing item X, this is writing item X. Now here what will happen? Let me tell you. This will be ignored. Okay, this will be ignored. So it is going to be ignored. Now this, you can see this schedule is view serializable. This schedule is not conflict serializable. And this schedule is allowed. This schedule is allowed by Thomas Wright rule with TSP. Okay. So you can see this is allowed by Thomas Wright rule plus TSP. So finally I can say that this statement is correct. This is view serializable. This schedule is view serializable. this schedule is not conflict serializable. So we can easily see that this timestamp protocol with Thomas Wright rule, it generates, it can generate, remember, it can generate view serializable schedules which are not conflict serializable schedules. So it can generate this type of schedule. So both are correct. Which statement are correct? I can say both the statements are correct. Okay. So this is another GATE exam question. Now let's see this one. This is another GATE exam, UGC NET exam question. This is UGC NET. Thomas Wright rule is related to, actually this is a poor question, let me tell you. This is very poor question. So this question should be asking like Thomas Wright rule is related to timestamp ordering protocol. Okay, this is related to timestamp ordering protocol. So the answer will be option B. Okay, now let's move on. Now let's see some Ullmann questions. These are Ullmann exercise questions. All the questions that I have taken, these are Ullmann exercise questions. This DBMS book by Ullmann. Okay, the name of the book, this DBMS book by Ullmann. Okay, so these Ullmann questions, let's see the exercise questions of this Ullmann. Let's see. Let's start with this question. Okay, look at this question. And what the question is asking, read this and let's solve this. I have full confidence on you. I have complete confidence on you that you can solve this question. Okay. So let's try this. What the question is saying, let's read the question. There are several sequence of events. First of all, start event. Okay. So the question is saying that STI means transaction TI starts. Okay. So like transaction T1 starts, transaction T2 starts, transaction T3 starts. Okay. So this is what STI means. STI means transaction TI starts. Okay. Now, timestamp scheduler will allocate timestamp to the transactions in the order of their starts. Okay. This timestamp scheduler, you have a timestamp scheduler that will allocate timestamps to the transaction in the order of their starts. In the order of their starts. Okay. Now the question is asking, tell us what happens when they execute. When they are executing, then what will happen? So let's see option number A. Okay, you tell me. This option number A, what is going to happen? So first of all, in the option number A, how many transactions you have? One by one you answer all the things. In this option number A, how many transactions you have? Only two transactions. One transaction T1, transaction T2, two transactions you have. Okay. So there are two transactions, T1 transaction, T2 transaction. Tell me which transaction has more timestamp. Tell me transaction T1, transaction T2, which transaction has highest timestamp? What is the order of timestamp? So you can see that transaction T1 starts first, then transaction T2 starts. So clearly what will happen? So at this point of time, you can clearly see what will happen, that T1 has less timestamp than T2. Okay, so this transaction T1 timestamp is less than transaction T2 timestamp, correct? Okay, because this T1 is a older transaction. You can easily see that first transaction T1 will start, then transaction T2 will start. Okay, T1 starts, then T2 starts. So you can see T1 is older transaction, T2 is new transaction. So transaction T2 has more timestamp than transaction T1, right? Yes or no? Okay. Now you tell me, is this allowed or not? Look at this. Read operation. So first it is reading item A, then it is reading item B, then this transaction T2 is reading item B, then this transaction T2 is writing item A. This is perfectly fine. Yes or no? There is no problem here, because this is the order of serializability. This is the order of serializability. So this is perfectly fine. There is no problem. Next, this T1 is writing item B. Next, this transaction T1 is writing item B. This is not fine. This is not allowed. Correct? Yes or no? So this is definitely not allowed. And because this is not allowed, so I can say that this will be unsuccessful. At this point of time, T1 will roll back. This operation will be unsuccessful. Remember, this operation is basically unsuccessful. This operation will not happen. Okay, this operation will not happen. This operation is unsuccessful. T1 will roll back. This is what happens in the timestamp protocol. It is what will happen in the timestamp protocol. Tell me, in the Thomas Wright rule, what will happen? Tell me a variation in the Thomas Wright rule. What will happen? Like timestamp protocol with the Thomas Wright rule. Now what will happen with the Thomas Wright rule? What will happen? Tell me. With the Thomas Wright rule, what will happen in the timestamp protocol? With Thomas Wright rule, is what is going to happen? What will happen? So you can see, because this is read-write conflict. Array, this is read-write conflict. So again, the same thing will happen here. T1 roll back. So the same thing will happen. The T1 will roll back because this is a read-write conflict. Understand that this is a read-write conflict. So in the timestamp, in the Thomas Wright rule also this will happen. In the Thomas Wright rule also this T1 will roll back. Okay. Same will happen in the Thomas Wright rule also. Okay, very good. So this is your question. In this question, I can say that what will happen in this question. We can just simply say that T1 rollbacks. Okay. This is the conclusion of this question, that T1 rollbacks. What about this question? Question number B. What about question number B? So question number B, how many transactions you have? What is the number of transactions? There are 2 transactions. You can notice transaction T1 starts. Then after some time transaction T2 starts. So there are 2 transactions, and you can see that T2 has more timestamp than T1 because T2 is younger transaction. So T2 has more timestamp. So let's see option number B. Option number B, there are 2 transactions T1, T2. T2 has more timestamp than T1. So this is the order of serializability. This is the order of serializability. You can see this is the serializability order. The conflict operation should happen in this order. In this order, conflict operation should happen. In this order, conflict operation should not happen. Should not happen. Okay, let's see. So now the question is saying that first this is reading item A. This is reading some item A. And then what is happening? Then you can see this is writing item B. This T2 is writing item B. It is writing item B. There is no problem. Next, then T2 is reading item A. T2 is reading item A. So again, there is no problem because there is no conflict. We have no conflict so far. There is no conflict. Then T1 is writing item B. Okay, then T1 is writing item B. This T1 is writing item B. So yes, there is a conflict, and this conflict is definitely not a fine. Yes or no? This is definitely not allowed. So you can easily see that this conflict is not allowed. This conflict, in this order, the conflict cannot happen. Remember, this is the order of conflict. Okay, the conflict operation can happen in this order, but in this order, the conflict operation cannot happen. So at this point of time, what will happen? At this point of time, you can see that T1 rollbacks. Okay, again here, what will happen? T1 will roll back. So this is what will happen. T1 will roll back here also. Okay, this T1 will roll back. So this is your answer here. Very easily you can see. Okay, T1 will roll back, not T2. T1 is going to roll back. Now, tell me the answer. If I ask you, if you use timestamp protocol with Thomas Wright rule, then what will happen? In the same question, if you use TSP with Thomas Wright rule, then what will happen? In the same question, if you use the Thomas Wright rule, then what is going to happen? Tell me. Thomas Wright rule. In this situation, this is right conflict. In this situation, you can see this is right and this is right. So this will be ignored. This will be ignored. Remember, this will be ignored. This operation WB will be ignored. Okay. This operation is going to be ignored, but the computation can go on. Like no rollback. No transaction will roll back. Okay. We will ignore this. This operation we will ignore. So this operation is going to be ignored. We just ignore this operation and we continue the operation. So the transaction will not roll back in this situation. Okay. So in this, I can say, because the question is asking for timestamp protocol. Remember, the question is asking for timestamp protocol. So here also I can say that T1 will roll back. Okay. What about the next one? The next question. There are 3 transactions and this is the order of their start. T1 starts, then T2 start, then T3 start. So this is the order of their timestamps. So you can see the C. In C, you have total 3 transactions, T1, T2, T3. This is the order of timestamp. So this is the serializability order. This is the serializability order, means conflict operations should happen in this order. In this order, conflict operations should happen. In this order, conflict operations should not happen. Okay. Now, what the question is saying, first you read, then you read A, then read B. So let's see this. Okay, it is reading A, then it is reading B. So far, no problem. Okay, then after that, then you are reading C, then you are writing C, sorry, writing C, then 3 is reading B, then this 3 is reading B. So far also there is no problem. No problem so far. Then this 3 is reading C. This 3 is reading C. This is fine. Okay, this is perfectly fine. There is no problem. So this is fine. After that you can see this W2B. After that you have W2B. So you are okay, you have W2B. Okay, there is a problem here. Again, there is a problem here. So this is the problem, W2B. So definitely, this is definitely not allowed, correct? This is definitely not allowed. And here at this point of time, what will happen? Your T2 will roll back. T2 is going to roll back. Okay. T2 will roll back. Remember, T2 is going to roll back. So now the T2 is gone. Okay. This is something important, that now the T2 has gone. Okay. So now forget about T2. Now T2 has gone. Okay. Now you remove T2. T2 has rolled back. So now you remove T2. Now you completely remove T2 because T2 has gone. So this T2 is rolled back. Okay. So this T2 has gone now. Clear? Now the T2 has gone. Okay. So now the T2, this T2, this transaction T2 is gone. After that, what is happening? This T2 is gone. Okay. So here something problem, here problem will happen and T2 is gone now. Then this T3 will write item A. Then this T3 will write item A. Then this T3 is writing item A. So that is fine. Yes or no? This T3 is writing item A and this is perfectly fine. This is perfectly fine. Okay. So this is what will happen. So you can see that this is the complete execution. So I can say that, I can say here T2 will roll back. In the question number 3, I can say that T2 roll back. This T2 will roll back in the question number 3. This is the problem. Okay. Now, okay, let's move on. The same, remember in the question number C, the same will happen for the Thomas Wright rule. For the Thomas Wright rule also the same will happen. Okay, this is interesting. Question number D. In the question number D, tell me what is the timestamp order? What is the timestamp order? In the question number D, what is the timestamp order of the transactions? What is the timestamp order of the transaction? That is T1, T3, T2. Okay, yes or no? So this is your option D. This is your option D. In the option D, you have T1, T3, T2. This is the order of timestamp of transaction. So this is the order. Okay, T1, T3, T2. This is the order, T1, T3, T2. Now you can easily see that first it is reading item A. First you are reading item A. Then what is happening? Then it is reading item B. So like this T2 is reading item B. This T2 is reading item B. Now after that, this writing item C. This one is writing item C. It is writing item C. No problem. So far there is no problem. Then T3 is reading item B. Then this T3 is reading item B. So far also no problem. There is no problem so far. Then T3 is reading item C. Then it is reading item C. No problem. Okay. Then T2 is reading item B. Then T2 is then T2 is writing item B. Okay. This T2, it is writing item B. Also there is no problem. So you can easily see that there is fine. This is perfectly fine. There is no problem. Okay. After that, this T3 is writing item A. After that, this T3 is writing item A. So this is also perfectly fine. There is no problem. Okay. This is also perfectly fine. So you can see there is no problem here. No rollback. Okay. In this question, I can say, this is, I can say allowed. Perfect. I can say this is, everything is perfect. Okay. In the question number D, everything is perfect. So there is no problem. So there is no rollback in the question number D. So in option A, B, C, there will be rollback. Here rollback, rollback, rollback. Okay. And in the question number D, there is no problem. Everything is perfect. So these are your Ullman questions. Very simple questions from the Ullman book. Can you try this quickly? Can you tell me quickly? Can you tell me what is the answer here? This is the Ullman exercise question. These are also Ullman questions 18.8.2. Okay, tell me about this one. 1, 2, 3, 4. You have total 4 transactions. There are total 4 transactions. Now you can notice, first you are writing, then it is writing, then it is writing, then it is reading, then it is reading. This cannot happen, right? Yes or no? This is not allowed. Agree or not? Agree or not? This is not allowed. Correct? This is not allowed. This is definitely not allowed. And because this is not allowed, so here T2 rollback. Here T2 will roll back. This is perfectly fine. There is no problem. This is perfectly fine. So here I can say that T2 will roll back. Okay. In this question, you can easily see that T2 is going to roll back. Okay. In this question, what happens? 1, 2, 3. 1, 2, 3, 4. Okay. This is writing item A. This is writing item A. This is reading item A. And then this is reading item A. This cannot happen, right? Yes or no? This is also not allowed. Again, you can see this is the problem. This is the problem. So you can see that this is not allowed. This is not allowed. So you can easily see this is not allowed. So again, here T2 will roll back. Okay, in this question also, T2 is going to roll back. So this is the problem here. In this question, this is the problem. In this question, this is the problem. Okay, let's move on. What about the next? 1, 2, 3, 4. Writing item A, then readings. This is also a problem, correct? Yes or no? So this is also problem. Okay, so again here T3 will roll back. So first of all, here you can see that T3 will roll back. But remember, after T3 rollbacks, this T2 will also roll back. This T2 will also roll back. Okay, please understand that here something interesting, T2 will also roll back. So this T3 rollbacks and T2 will also roll back. So T3 and T2, both of them will roll back. Okay. In this third one, T3 also roll back, T2 also roll back. 2 transactions will roll back in this one. Okay, both of them will roll back. T3, T2, both of them are going to roll back. Okay, so these are your some Ullman questions. I hope you liked all the questions that we have seen. So that's it. This is all the timestamp protocol we have already seen. So please tell me, did you understand everything in the timestamp protocol? Let me know. Did you clearly, in a very crystal clear way, did you understand timestamp protocol? Let me know. SG Dangerous Khiladi, please tell me. Let me know. So this timestamp protocol, is this crystal clear? More than 65 questions we have done. More than almost 60-70 questions we have done on the timestamp protocol. All the variations, everything we have seen. Okay. Now, what is the relation between timestamp protocol and two-phase locking protocol? So what is the relation? What is the relation between timestamp protocol versus two-phase locking protocol? What is the relation? So let me tell you that if these are the schedules, these are the conflict serializable schedules. Okay, let me tell you. Both of them will ensure conflict serializability. These are all the conflict schedules. These are all the conflict serializable schedules. These are all the conflict serializable schedules. Now. Okay, some of them are allowed by timestamp protocol. Some of them are allowed by two-phase locking protocol. Okay, but remember, this is the complete connection. Okay, this is the complete connection between timestamp protocol and two-phase locking protocol. So both of them will ensure conflict serializable schedules. These are the conflict serializable schedules. And you can notice these are the timestamp protocol schedules. These are the 2PL schedules. These are both of them. These are none of them. Okay, so these are basically these two concepts. They have nothing to do with each other. Yes or no? Yes or no? These two concepts, timestamp protocol and two-phase locking protocol, these two concepts have nothing to do with each other. Okay, they have nothing to do with each other. You can create a schedule which is allowed by timestamp protocol but not allowed by 2PL. You can create a schedule which is allowed by 2PL but not allowed by timestamp protocol. You can create a schedule which is allowed by both of them. You can create a schedule which is not allowed by both of them. This is the connection. This is the complete connection between timestamp protocol and two-phase locking protocol. Okay, this is the connection. Now let's see example. So you can easily see that there are schedules. You can easily see there are schedules that are possible under two-phase locking protocol but not possible under timestamp protocol, and vice versa. So you can easily see this example. Tell me, is this allowed by look at this, is this allowed by timestamp protocol? Simple question I am asking, is this allowed by timestamp protocol or not? Look at this question and tell me, is this allowed by timestamp protocol? Can we allow this in the timestamp protocol? So let me assume this is the timestamp ordering. So can we allow this in the timestamp protocol? Do we have okay, so what is the order here? So let me check. I think this example is not correct, but let me give you a schedule which is allowed under this. Okay, so this is actually not valid, or maybe what you can do, so actually what to do here, just take this timestamp ordering. Look at this timestamp ordering. This timestamp ordering I am giving you. Consider this timestamp ordering. Consider this timestamp ordering that you have T0, then T2, and then T1. Okay, consider this timestamp ordering. Consider this timestamp ordering that T0, then T2, then T1. Okay, so this is your timestamp ordering. So basically what I can say, I can write it. You can just check it. Just give me a second. Hello. Yes. So let's see this timestamp ordering. So if you have this timestamp ordering, like you have T0, then T2, then T1. If you have this type of ordering, then let's assume this is writing item A, then this is writing item A, then this is writing item A. This is perfectly fine, correct? Okay, this is perfectly fine. There is no problem. So here it is perfectly fine. After that, you can see that after that, this is writing item B, and then this is writing item B. This is also perfectly fine. Okay, so this is allowed by 2PL. Sorry, this is allowed by, I can say, timestamp protocol allows. Correct? Timestamp protocol will allow it. This will be allowed by the timestamp protocol. Okay, so there is no problem. Timestamp protocol will allow it. And what about this 2PL? What about this 2PL? Like this T0 and T2 and T1. Okay, what about this one? This write item A, write item A, write item A, then write item B, and then write item B. Will 2PL allow it? Check if 2PL can allow it. Is this 2PL schedule? Like 2PL allows it? Tell me, does 2PL allow it? This schedule, is this allowed by the 2PL? Does the 2PL allow it? So let's check. So you can see that here you need exclusive lock on A. This exclusive lock you need on A. Then you can do this operation. There is no problem. You can do this operation. Now there is a problem. See. If you want to do this operation, what you need? Which type of lock you need? Tell me. If you want to complete do this operation, which type of lock you need? Let me know. See, this T0, it can take exclusive lock on A, then it can do the this write operation it can do. Now, you want to perform this write operation on A, you need exclusive lock. You need exclusive lock here, right? So if you need exclusive lock, then this T0 must unlock, correct? If you need exclusive lock on A, then this T0 must unlock. If T0 is unlocking, then it will go to, remember this T0 is unlocking A, then it will go to shrinking phase. In the shrinking phase, it cannot take lock on B. In this shrinking phase, it cannot take lock on B. Okay, you cannot take lock on B in the shrinking phase. So what you can do, you can take a lock on B before this. Like for example, you can take exclusive lock on B and then you can unlock. Then fourth, you can unlock A. And then you can take exclusive lock on A and then you can do this operation 6. Then you can, then you have to unlock. Okay, no problem. You can unlock A. Then you can take exclusive lock on A here. Okay. Then you can do this operation. After that, you can perform this operation. So, right, this is actually allowed by 2PL. This is actually allowed by 2PL. Okay, there is no problem here actually. This is allowed by 2PL because you can just do this, like this 10 you can do, and then you can unlock, B, and then you can exclusive lock on B, and then you can do this. Okay, so this is actually allowed by 2PL. So I think this example will not work. So we need to find some other example. Some other example we need to find. Okay, so some other example we need. Such that it is allowed by timestamp protocol, but it is not allowed by 2PL. This type of example we need. Any suggestions? We need an example where it is allowed by timestamp protocol like T1, T2. It is allowed by this timestamp protocol, but it is not allowed. This type of schedule we need where timestamp protocol is allowed, but not allowed by this 2PL. Okay, two-phase locking protocol. By that, it should not be allowed. So in this previous question, actually, can we do some modification? In this question, can we do some modifications such that we can do it? Can we do some modifications such that it will not be allowed by 2PL? By 2PL, this will not be allowed. So okay, so anyway, let me check it. See, this type of schedules are possible, but right now I can't think of anything. So anyway, this type of schedules are possible. I will check it and I will tell you in the next lecture. I can tell you. So there are schedules which are allowed by TSP, which are not allowed by 2PL. Okay, this type of schedules are there. Which are allowed by timestamp protocol, but they are not allowed by 2PL protocol. Okay, this type of schedules are there, but right now some example we can't think. So let's move on. Let's see this one, which is this type of example is very easy. Which type of example? Which is allowed by 2PL but not timestamp protocol. This type of examples are actually very easy. which are allowed by 2PL but not allowed by timestamp protocol. For example, consider this example, like T1 T1 timestamp is less than T2 timestamp. Now you can just simply see this example, like read item A and write item A. This example you can easily see that this example you can see that this is 2PL. This is 2PL, but this is not allowed by timestamp protocol. Okay. So this example is very easy actually. So anyway, finally what I want to tell you that both of them will allow conflict serializable schedules only. So this is like, I can say these are all the conflict serializable schedules. These are all the conflict serializable schedules. So these are your conflict serializable schedules. These are the schedules which are allowed by timestamp protocol. These are the schedules which are allowed by 2PL protocol. So like this is the relation between what are the schedules generated by timestamp protocol and what are the schedules generated by 2PL protocol. So this is your chapter and we are done with this timestamp protocol. So we have seen this timestamp protocol, the complete explanation of timestamp protocol. We have seen all the variations and everything. So I hope you understood all the things. So thank you everyone. And this timestamp protocol, let me tell you, all the variations we have covered, all the type of questions, all the gate questions we have covered, all the standard questions we have covered, each and every variation that can be asked in the gate exam, whatever variation they will ask you, whatever they can ask you, whatever variation they can create, any creative question they can create, we have already done it. Okay. So this is the complete explanation. Let me tell you, complete explanation, complete analysis of timestamp protocol. So the last lecture you can watch. In the last lecture, 50 questions we have done. Okay, 50 standard questions of timestamp protocol we have solved in the last lecture. And in this lecture, we have seen Ullman question, Washington University question, and the gate questions. Okay, so this is the complete package. I can say this is the complete analysis. This is the complete explanation of all the details of timestamp protocol we have covered. Okay, there is no question they can ask you outside of this. Okay, so whatever the question they will ask you from whatever we have seen, because we have covered each and everything. Okay, so thank you everyone. Please like, comment and share. Okay, so you can comment and you can tell me what did you like about this session. Okay, so what did you learn, and basically which question did you understand everything? So you just let me know, like, did you understand everything? So you just give me your review in the comments. Okay, so like, comment and share.